Good morning, Smriti. We will still wait for your friends to join the session. Okay, we shall begin. In the last session, we have seen. Yes. Okay. In the last session, we have seen vector, linked list, So far we have seen these classes, array list, right? And is anybody having any questions in these classes? We have seen two interfaces also, the main interface collection. Then we have seen how to use iterator to iterate through the collection using the iterator interface, and the different methods of adding and removing the collection elements. Is anybody having any questions so far? Okay, okay, fine. Then, yes. Then, what portion of collection we have seen is collection. Then you have list interface inside collection interface. We have queue interface inside collection interface, and we have set interface. In list, we have array list class, vector class, linked list class, and stack class. Now, before we move on to other interfaces and their classes, I like you to try on your own the implementation of stack interface, stack class. Using list interface, how can you create stack classes object, and what type of elements? Can you apply generics over here? Can you apply generics here? If you can apply generics, what all functions of stack class is allowing you to add and remove the elements from the stack? How to add and remove the elements from the stack, and how to iterate through the stack? Can you use the iterator here or not? Or can you use the enhanced for loop to print the elements of a stack or not? I would like you to research this on your own. Please open your editors and let us try how to implement stack with the help of list interface. And let's see what all methods you have in this stack class. Definitely the methods of add and remove. Logically, we can think from what so far we have studied that you can push the elements onto the stack, and you can pop the element from the stack, and it follows last in first out order, LIFO order. Okay. Or it follows first in last out order, FILO or LIFO. This order is being followed by stack. Let us see. Please try to implement stack on your own. Let us see, can we do it with using this push and pop methods or not? And can be used enhanced for loop or iterator to iterate through stack or not? Please try this on your own. If you are facing any difficulties, let me know. I will help you out. Yes, anybody done with implementation of a stack, or you are still working on it? It is very simple. Okay, no problem. It is very simple. Just create the reference of list and object of stack, because list is an interface. You cannot find implementation of list with itself. You need to find implementation of list with its subclasses.
Ma'am, it's done. Hello, ma'am.
Yes, sir. Please share your screen.
Yes, ma'am.
Yes, you are using stack of integers. Okay, you are adding values and then you are iterating. Okay. Uh, Push is also working and add is also working. Both the methods are working.
Yes, ma'am.
And get is used for retrieving single elements till the size of stack. Oh, good. And pull and pop will only delete the topmost element from the stack, right?
Yes, ma'am.
Yes. Correct. Yes, very good. Anybody else done with the stack implementation? Yes, anybody else done with the stack implementation? They can share their screens. Okay, fine, no problem. Then I would like to move to another. Let me share my screen. Another interface, that is queue. And are you able to see my screen?
Yes, ma'am.
Yes. Okay. And queue interface is having its implementation in priority queue and Deque. Now, priority queue, as you already know, it creates a queue based on the priorities, and queue is actually a first in, first out structure, like the railway reservation window, where who is first come first serve basis, served according to whoever is appearing first in the queue. According to that only the elements are served and popped off. You can say dequeued from the sequence. Now, priority queue actually works with priority of different elements. Then, what do you mean by priority, and how can we set the priority here? That is the question. Usually, say for example, if I create the reference of queue using, say for example, a string as generics, and I create the object of priority queue, again of type string itself, then based on the priority of the ASCII values, the records are sequenced in the queue. In the sense, if I add, I don't know what is the method here, whether it is add, push will not be there for sure. Whether it is NQ, whether it is DQ, I don't know the methods. I want you to explore that, but still I'm giving you the hint. If I am adding certain value, like DEF, then I am adding one more value, say for example ABC, then according to, and say for example FFF and some GGG, okay, then according to the sequence of the ASCII value, the priority is the sequence of the ASCII value. According to that only the elements are added onto the queue. Please try to implement queue and check whether it is working according to the ASCII priority or not. I want you to explore this on your own. Create one reference of queue and object of priority queue and check how the elements are added, what is the function for removing, adding, and one more thing, check is it ASCII based or can we set our own priorities or not. Please check it on your own. I wanted to explore this. Everybody should try. Please try this.
I tried. I pasted the output in the chat box.
Yes, you are getting. Okay. Can you share your screen once?
Yes,
G,
ma'am.
B, C, D, E, F, G. F should come first actually. Let us check once. You are okay. A and D is sorted properly according to the ASCII value of F and G. F should come first, and then G should come right.
Yes, ma'am.
If you simply add just one character F and G, then what is happening? Will you please check? I
Yes, ma'am.
think because the ASCII value here is 0. If you try to, yeah, now if you try again G and F,
And because DEF, so after G is a कुछ.
D, E, F, G, then again F is coming. Otherwise, it should not be like that.
हाँ, yeah.
Yeah, yeah. It actually adds based upon the ASCII value only. Try to run it again once. It is not changing, right? If you add F, then G only should come because
Yes,
that is
ma'am.
the default priority that they have set. According to ASCII only, it will come. You are creating the object of priority queue. Yes, then it should work like that. Dot v dot add. Then we are printing it. A and B are coming in sequence, but if you try to create integer in this, will you try it once?
Yes,
Try to create integer. And, let's see if we can. And if you want to remove the last element, then we use the function poll. Poll is used for removing the last element.
which ma'am?
Poll, P-O-double-L. Scroll down. No, P-O-double-L. P for pink, O, yes. 236, right?
Yes, ma'am.
Yes. And 1 is, see how it is served. It is served using first come, first serve. No? So if you are adding 1, any which way, if you are, it is already arranged in the sorted fashion, then 1 is always served first. So it is serving from that only. This way it is getting correct, but for string, I will check it again on my own why it is not working fine.
Ma'am, but before this poll function, it was not sorted.
Yes, yes, but when it stores, no, okay, like that you are telling.
Yes, ma'am.
Because see, hashing is not there, so random sequence cannot come. It should be, according to the descending or descending order only. It cannot arrange in a random fashion. Natural ordering should be there. Natural ordering is in the sequence only. Okay, I will check it on my own why it is working like that. But usually priority queue is based on the priority, and priority is usually our ASCII value only because it doesn't know how to set the priority. So it sets according to our ASCII value only. Okay. And what other functions do you have? Please try once. G dot. You have remove, right? Yes, remove. If you simply call remove, it will remove
Yeah.
the first occurrence. Yes, just like Paul, it removes the first occurrence and
And then
remove.
what is the difference between poll and remove?
See, the Paul is actually the function of priority queue, but remove is since collections. Remove function belongs to collection interface itself. Since list we are seeing remove, no.
Yes,
It
ma'am.
is a function from collection, but priority queue's function is call, like that. Yes. Okay, okay, no problem. I will check it on why it is not sorting the other two. Why it is only sorting the first, I will check that in strings. Okay. Okay, apart from this, anybody is facing any problem in understanding how stack is working, how queue is working, how priority queue is working? Is anybody having any questions so far? Okay, 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 fine. Then again, you have, let me share my screen again. Yes. Then this DQ is actually an interface, which is again a sub interface of Q. So DQ extends Q actually. And this DQ finds its implementation in its subclass known as ArrayDeque. ArrayDeque is the subclass of DQ, and DQ interface is the sub interface of Q interface. Like this, what do you mean by ArrayDeque? DQ is nothing but from both the ends you can remove and add the elements. That is the use of DQ, right? DQ is nothing but you can remove the elements from both the ends. So, just like you have seen the function call for removing the topmost element of the queue or for serving the first element of the queue, here in your ArrayDeque class, you will find the functions like call last to remove the lastmost element. Then it may have the functions like whenever you are adding the element on the cube, it is simple add function, okay. You also have the function, you also have the possibility of adding the element from the first position itself. You can remove from the last position, you can add from the first position. Just like stack, you can add on the top, and like DQ, you can remove from the last. This may not be add first, it may be something else. Just look at the methods. But just like you had Paul for removing the first occurrence or the first person that you are serving for the queue, you can also serve the last person also by Paul last. See if you are having these methods in your ArrayDeque class or not. You can create your ArrayDeque classes object by creating your DQ's reference first. You can create with string, it doesn't matter. And you can create the array of the object of ArrayDeque class. And d dot you can call add. I think add is there for adding the elements. I think one more method is there. Offer. Offer is actually used for adding the elements in DQ. See if you can add the elements using offer or add, and you will have call for removing the first element, call last for removing the last element, and here it should be offer. If offer is working out, then offer first is the method for adding the elements on the top. Just see if you can create the object of ArrayDeque or not. DQ is the interface, ArrayDeque is the implementation. So DQ finds implementation in this class ArrayDeque. Again, both these are residing under the hierarchy of queue itself in your collection interface, collection API. See if you can use these methods or not by creating the ArrayDeque object. Please try. Krunal. Yes, Krunal, you had any question?
Ma'am, done.
Yes, yes, yes. Please share your screen. You have method like, oh, of course, there is. That is good. Then you have add first, add last. All last will be removing the last element. Yes, correct. And add first is adding this as first, and add last is adding it at last. And then you are removing the last, so it is removed. Oh, okay, good, good, good. Yes, yes, yes. So DQ is the same way you have no problem. Kunal. DQ is the same implementation that you have seen in data structures, right?
Yes, ma'am.
Double ended. Yes, good. Yes, yes, you can share screen. Yes, is anybody facing any problems in implementation of these topics? You can share your screen or unmute yourself and talk to me. I will help you out. Yes, is anybody facing any challenges or problems in understanding these topics that we have seen so far? Yes, anybody facing any difficulties in understanding these topics that we have seen so far? Queue, we have seen queue, priority queue, and DQ, ArrayDeque. Anybody is struggling with any problems in these topics? Okay, okay. Then I want to show you this side, set side of the collection interface. We have a set actually, and set is finding its implementation in hash set. We have preset, and just like we had a sub interface here, no, DQ. Here in set, we also have one sub interface known as map. And map finds its implementation in hash map. We are going to see this one by one. Let us first look at the set part of the collection interface. Set, whenever you are trying to implement list, if you remember, or let us say when I will show it to you here itself, if you are trying to implement a list interface, and say for example integer itself I am implementing list, new array list, say for example, and you are trying to add the elements here, then it is possible to have duplicates over here, meaning your list can allow duplicated values. Now let us see what is going to happen if we use set here instead of list. If we try to implement the set interface finds its implementation in hash set and be set later on. Let us first try to see what is hash set and how it is working. If we try to use hash set and the method is the same for adding and removing, the method is the same, there is no change. If we try to run this now, it is not allowing the duplicate elements. It is not allowing to add duplicate elements. So whenever you feel that you don't want to add multiple entries in your data structure, if you want to if you don't want to allow that, like say for example, email addresses are never duplicated, or your enrollment numbers, they are not duplicated. Those kind of, or user IDs, employee code, employee IDs, these stuff, phone numbers even, these things are non-duplicated all the time. Then we use the implementation of set apart from list. But again, iteration is also same. Using the iterator here, you can use the iterator to parse through your complete collection, doesn't matter, L.iterator. And you can even use your enhanced for loop to iterate through your complete collection, that also doesn't matter. Complete set doesn't matter. So accessing and retrieving is not a problem over here. But here duplication is not allowed. That is the only difference between list and set. One more thing to notice here is that duplication is not allowed. That is the first thing. Let me show you one more thing. Before that, I want to show you another thing. If you look at your add method in the complete collection interface, the complete collection API is returning Boolean. We haven't noticed it so far, but I'm telling you this now. It is returning Boolean. Why I am telling you this now is, now whenever you want to add duplicate elements, I am trying to print whether the addition of this element to your set is allowed or not. If I am trying to print whether it is allowed or not, or whether it is returning true or not, it is definitely not going to return true in the duplicated values, because the addition operation has not been successfully done. If we run this now, we can see for the first three values where values are currently added, it is returning true. For the fourth record, it is printing false and then again true, because it is a non-duplicated value. So your add function is going to return true when you are trying to add the element for the first time, and for all the other tries, when you try to add the element, it is going to return false. One more thing I would like to share here is that the order in which the elements are added. Say for example, I am adding the elements in haphazard fashion. Let us add a few more elements. And now if we run the program, you can see that the output is not in the fashion that we expected, or the elements are not added sequentially. It is of course right, the elements are not added sequentially in your set. The reason is that your set finds its implementation in hash set, and here hashing is required to store the elements. And what will hashing do? It uses the mathematical formula for storing the elements in the hash table. If you remember from your data structure sessions, then your hash table will use the modulus operator for finding the location of your element. In the sense, if I'm just giving you one small example, not to worry. It is, say for example, your hash table is of size 5, and you want to add the elements like this in your hash table. Then it is trying to mode your element with the size of the table. And whatever is the answer for that index 0, 1, 2, 3. Okay, so for this index 3 is stored. So that retrieving the element is very easy. Always f of x is x in your hash table, in the sense your third element will be placed at third index only, and your fifth element will be placed at a fifth index only. But whenever we come to restricting the size of the hash table and the elements are more, or the element that you want to add is beyond the size of the hash table, then it tries to mode that element with the size of the hash table. And if the output, or if the collision occurs here, you see, whenever I try to store 8, the remainder is 3. Whenever the collision is occurring according to your data structure, it can solve this collision of 2 elements at the same place or multiple elements at the same place by using linear probing or chained hashing. And in Java, your hash set is implementing chained hashing, in the sense these elements are pointed like nodes, created like nodes, where 3 is linked with 8, and whatever elements come after that is linked with that, and whatever elements come after that is linked with that, in the terms of chained hashing. So if you are searching for the third position, then if you are searching for the element of, say for example, 8, then it checks the remainder of this division and it searches whether the element is present in this location or not. Like this chained hashing is implemented in Java with the use of hash set, and that is the reason the output of a hash set will never be in the ordered sequence, because it uses the mathematical formula for storing the elements in your hash table via hashing method. That is the reason the output will never be in a sequential fashion. Yes. And of course, you can definitely use your enhanced for loop here, for sure. You can use your enhanced for loop for iterating through your L, meaning your set for sure. Actually, I is used over here, so it is not allowing. Well, we can use some another variable, and then you can print these values. Again, the output is going to be same, of course, and see, so yes. And for removing the elements from your set, the method is remove. Remove a particular record from your hash set. The method is remove itself. Set is not having its own methods for deleting or removing the element. See, you don't have set's own method for deleting or removing the records. It is using the collections interface method, remove and add for adding and removing. Remove all will remove the complete collection, and add all will add one of the collection to your collection. It is very simple, nothing major in that. If you have one more collection L2, then you can add your complete collection L2 in your collection L. That is the use of add all. There is nothing specialty in there. One more thing I would like to show it to you is your toArray function. You can always convert your collections to array by the use of toArray functions. You can see it returns the output of type object array. So, and then your object array can be converted to whatever data type you wish to convert. It is okay, because object can be converted to string, object can be converted to integer, object can be converted to double, also anything. So you can simply create an integer array, and size of array.length. It is very simple, array.length, and you can, in the for loop, you can convert your j less than length and j plus plus, and you can convert your array of I to your array of j, like this, right? Incompatible types. Okay, so we'll just require some conversation over here. Maybe integer dot some method of integer, wrapper class which can convert object to okay, fine. If we can apply typecasting or some method of object class, or maybe we are able to apply typecasting here. Let us see if we can apply typecasting. Yes, yes, you can apply typecasting here, and you can allow your object to convert to integer easily, and it can be stored in integer array like this. So toArray is a function which is allowing us to convert your collections to array if you wish to. Same for double, same for float, same for string. It stands on the same basis and no difference. Yes, is anybody having any questions so far? Okay. What about others? Okay, fine, no problem. then we will see this topic of tree set. Tree set I can show right now only. We still have time. If you remember your binary trees, where the data is stored in a sequential fashion, if I implement set with the help of tree set, the only change here is that, let me comment out the extra code. The only change here is that now it is going to implement in terms of tree. So your output will be in a sorted manner. Where is yes, here. The output will be added in the sorted manner. Whenever you are trying to use tree set, it is implementing the binary trees over here, and it is allocating the memory in such a way that it is creating a balanced tree in such a way that it creates it in a proper navigatable way, and it sorts the records and then adds it to the tree. So it is going to always be in a sorted fashion. Whenever you are again it is not going to allow duplicated values for sure. Duplications are not allowed in any of the set. Whenever you are implementing set, duplication is not allowed, so that is for sure. But again, you can sort it like this, right? One more function of this tree set, whenever you are free, please try to explore. Let me see if I can show it to you or not. Tree set, maybe that will be of type string only. Okay, let us see if we can head. No, it is not shown here. Oh, that is okay. But what I was trying to show you is that you can even sort it in a decreasing fashion. But let me explore more on those methods. It is not seen over here. Otherwise, you can reverse the collection like we have done. You can reverse the collection, and you can definitely do that. With the iterator, I think with the iterator, you can make it point to. Again, okay, fine. Yes, okay. I'll explore more on that. But you have something which can reverse is there for sure. But reset is having its own method for reversing this collection. That I'll let you know in the next session, because I'm not finding methods for that right now. I have to explore more on that. Or maybe we can create some methods, but we can reverse the collection completely without using collections reverse method, with using tree set as implementation also. Because tree set is automatically sorting it in ascending, then it is having no problem in sorting the records in descending. That we'll see it in the next class, no worries. But these are the differences between the set, list, and hash set and tree set. Okay, is anybody having any problems in understanding so far? Okay, fine, no problem. Yes, I'll take the attendance and then you all can leave the session. Yes. Ayush,
Present, ma'am.
Rohan, Vipin,
Present, ma'am.
Manav,
Yes, ma'am.
Anuj, Riddhi. Riddhi is there. Yashraj, Ash, Mansi,
Yes, ma'am.
Nikita,
Yes, ma'am.
Manthan,
Present, ma'am.
Amit Kumar, Devansh,
Present, ma'am.
Ala,
Yes, madam.
Yashang,
Yes, ma'am.
Vipin,
Yes, ma'am.
Tushar,
Present.
Yash,
Present.
Maniyar,
Present, ma'am.
Parmar,
Present, ma'am.
Udayraj, Rishabh, Ivanchi, Janvi,
Present, ma'am.
Banushali, Vijayraj, yes, Rishabh is present. Vijayraj, Deep,
Present, ma'am.
Bharti,
Present, ma'am.
Abhinash,
Present, ma'am. Present, ma'am.
yes. Who else is present? Ranjul, Limbani,
Present, ma'am.
Arjan,
Yes, ma'am.
Maharana, Anmeraj,
Yes, ma'am.
Dignesh Prasad, Anjwani, Kushil Prasad,
Present, ma'am.
yes. Dhruvi, Naitik, Harmik, Mohammed, Runal,
Present, ma'am.
Nidhi,
Yes, ma'am.
Arpit,
Yes, ma'am.
Meghna, Yash, Divya, Saif Ali,
Yes, ma'am.
Samir Alam,
Present, ma'am.
Isha,
Present, ma'am.
Vibhusha,
Yes, ma'am.
Om, Aditya, Diplani, Aditya Jain, Jay Dakan, Priyank,
Present, ma'am.
Tushar, Nikita, Girish,
Ma'am, Nikita present.
Present, ma'am. Ma'am, Girish present.
yes, yes. Pick
Yes, ma'am.
enrollment number 62. Shri is present. 61, 59, 60, 63, 64, Ima, 65,
Present, ma'am.
73,
64 present, ma'am.
yes, Ima, yes, 73, Mohammed is present. 67, Darshan,
Present, ma'am.
yes,
Ma'am, 73 present.
yes, Jaideep, Smriti is present. Vaishali, English present. Nasi,
Present, ma'am.
yes, Jaideep, I have marked your presence. Kunal? Kunal Joshi is there. Palivad? Palivad is not there. Yes, Meghna has marked your presence. Vignesh Prasad, yours also have marked as presence. Kunal, you also can leave the session.